Hi friends, this is Atanu Chaudhary of SureSolve. Today in this first part, we'll take up the SSC CGL solution set 16 on trigonometry 2 from suresolve.com and solve the first 5 questions. Let's solve the first of this difficult set of problems. Question 1 is, the simplified value of sec theta minus cos theta whole square plus cosec theta minus sin theta whole square minus cot theta minus tan theta whole square is option A half, option B 0, option C 2 and option D 1. In most trigonometric problems, the key to quick solution is to simplify a sum of inverses expression like sec theta minus cos theta by itself to first form sin square theta by cos theta. Instead of two terms, you have now a single term, a significant improvement. Sec theta minus cos theta equal to 1 by cos theta minus cos theta equal to 1 minus cos square theta by cos theta equal to sin square theta by cos theta. In the next step, simplify the single term further and bring in tan theta, because tan theta appears in the third square expression. You get sec theta minus cos theta equal to sin square theta by cos theta equal to sin theta tan theta. Square up and the first expression is transformed finally to sin square theta tan square theta. In the same way, transform the second square expression to cosec theta minus sin theta whole square equal to 1 minus sin square theta by sin theta whole square equal to cos square theta cot square theta. Now taking up the third expression, identify the pattern that in its expansion you will get the terms tan square theta and cot square theta, which you will be able to combine conveniently with the first two results. Let's show you the results. The direct expression is E equal to sin square theta tan square theta plus cos square theta cot square theta minus, in the brackets, tan square theta minus 2 plus cot square theta. Equal to 2 minus tan square theta multiplied by 1 minus sin square theta minus cot square theta multiplied by 1 minus cos square theta. Equal to 2 minus, in the brackets, sin square theta plus cos square theta. Equal to 1. Answer is option D 1. Can be quickly solved by applying the simplifying concepts in stages if you can see through the possibilities. Next problem. Question 2 is, if sin theta plus cos theta divided by sin theta minus cos theta equal to 5 by 4, then the value of tan square theta plus 1 divided by tan square theta minus 1 will be option A 41 by 40, option B 40 by 41, option C 25 by 16 and option D 41 by 9. Applying the powerful component dividend technique on the given expression, we get directly sin theta by cos theta equal to 5 plus 4 divided by 5 minus 4 equal to 9. Or tan theta equal to 9. What we have done, we have added 1 to both sides of the equation first, then subtracted 1 from both sides of the equation, and in the third step of componendo dividendo, divided the first result by the second. The whole process can easily be carried out in mind in a single step. Now substitute the value of tan theta equal to 9 in the target expression and get E equal to 9 square plus 1 divided by 9 square minus 1 equal to 82 by 80 equal to 41 by 40. So the answer is option A 41 by 40. Thanks to the application of the method of componendo dividendo, the problem can quickly be solved in just a few steps. Next problem. Question 3 is, If sin theta plus cosec theta equal to 2, then the value of sin to the power 100 theta plus cosec to the power 100 theta is option A 100, option B 3, option C 2, and option D 1. Whenever the target expression involves large powers of sin theta or cos theta, we can be sure that from the given expression we would get either the value of theta or the value of sin theta. Otherwise, such large powers cannot be evaluated by direct deduction. With this knowledge, we start working on the given expression. Sin theta plus cosec theta equal to 2. Or sin square theta minus 2 sin theta plus 1 equal to sin theta minus 1 whole square equal to 0. Or sin theta equal to 1, and so cosec theta equal to 1. Putting these convenient values in the direct expression, we get E equal to 1 plus 1 equal to 2. So the answer is option C, 2. Let's move on to the next problem. Question 4 is, the greatest value of sin to the power 4 theta plus cos to the power 4 theta is option A 1, option B half, option C 3, and option D 2. Using the concept of algebraic maxima finding technique, we transform part of the given expression to a perfect square of sum. Sin to the power 4 theta plus cos to the power 4 theta equal to sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta. Equal to 1 minus 2 sin square theta cos square theta. As both factors of the negative second term are in squares, the numeric value of the product must be positive or 0. That means the maximum of this expression can only be 1 when the second term is 0. That is, when either sin theta or cos theta is 0. This is a quick method as it has used the trigonometric relations along with the algebraic maxima technique. Answer is option A 1. Last question now. Question 5 is, if sin theta by x equal to cos theta by y, then sin theta minus cos theta is option A x minus y, option B x minus y divided by root over x square plus y square, option C y minus x divided by root over x square plus y square, and option D x plus y. Though the direct expression looks simple, the task is cut out for us. We must express both sin theta and cos theta in terms of x and y. With this goal, we start manipulating the given expression in the simplest path possible. Sin theta by x equal to cos theta by y, or cot theta equal to y by x. Or cot square theta plus 1 equal to cosec square theta equal to x square plus y square divided by x square. Or sin square theta equal to x square divided by x square plus y square. Or sin theta equal to x by root over x square plus y square. Similarly, cos theta equal to y by root over x square plus y square. So the direct expression is E equal to sin theta minus cos theta equal to x minus y divided by root over x square plus y square. Answer is option B, x minus y divided by root over x square plus y square. To read the detailed solutions, refer to the article in suresolve.com. Link is given in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.